Welcome, ladies and gentlemen, to your MN15 notes, where we're going to talk about the converse of the Pythagorean theorem. In your MN14 notes, which is associated with section 7.1, we've been talking about the Pythagorean theorem and how if you're given a right triangle and two sides, you're able to find the third side using the Pythagorean theorem. The converse is exactly opposite thinking. So what we don't know is if we have a right triangle, but we are given three sides of a triangle. So if in fact the Pythagorean theorem checks out or works, then we can conclude that it is a right triangle. So before it was given a right triangle, find your sides. In this, we have our sides, but we want to test or determine whether the triangle is a right triangle. So it's converse or reverse thinking. So example 1, it says, tell whether the given triangle is a right triangle. So that's the whole point of this, is we're just wanting to know if we have three sides of a triangle, if this is in fact a right triangle. So we're going to start by putting the Pythagorean theorem up, which we're very, very comfortable with now because we've been working on it for a while. And just looking at this triangle, it seems like 3 squared root of 34 is the longest side, which is the hypotenuse. If you're not quite sure, what you would want to do is you would want to take 3 times the square root of 34, which I'm going to do here, and find the approximation to it. So 3 times the square root of 34 is going to give you approximately the value 17.5, rounded to the nearest tenth. And be sure to do that in your calculator. Know how to use those square root buttons. I've mentioned that before, and it's just a place that I see students sometimes struggle. So clearly that this is, or would be, the hypotenuse of the triangle if it's a right triangle. So let's kind of test to see whether or not this is a right triangle by seeing if it fits the Pythagorean theorem. So we're going to put 9 in for A, because it's one of the legs. So we've got a leg here and a leg here. And we have 15 squared. And we want to know if it's equal to, and I'm not going to use the rounded version because there's already a rounding in there. I'm going to use the exact value of 3 squared root of 34. I'm going to square that and see if this checks out. If it checks out, it's a right triangle. If not, it's not a right triangle. So 9 squared is 81, plus 15 squared is 225. And this over here is what we have to be careful with on this right-hand side. I'm going to expand it out. So 3 squared root of 34 squared is 3 squared root of 34 times 3 root of 34. Now, I'm going to multiply those two numbers together, but on the left side here, let's just simplify this one last step. That 81 plus 225 is 306. 306. And again, we want to know if it's equal or not equal to that right-hand side. Now, when we multiply these two values together on the right side, we're going to multiply the 3 and the 3 together. So 3 times 3 is going to give you 9. And that square root of 34 times the square root of 34, whenever you multiply a square root times itself, you get what's under that radical. So square root of 34 times square root of 34 just gives you 34. And we've been working on that, but it's been a little while, so I just wanted to make sure I reviewed that. So 9 times square root of 34, the question, or the big question is it 306? So 306 equals 9 times 34 is 306. So this is actually checking out, which means that the Pythagorean theorem is working here. If the Pythagorean theorem checks out like this, that means we can say yes, and I'll put it right way up here. Yes, it's a right triangle. So that is our answer to this problem right here. Now, what you should ask yourself is, okay, well, fine, it checks out. So what if it doesn't equal? What is it then? Are we just going to say, no, it's not a right triangle? Well, if it doesn't check out, that means that it's going to either be an acute triangle or an obtuse triangle. And this is where the full Pythagorean theorem converse is coming out. So let me just kind of write this all down. It says if, and this is the one we just talked about, if a squared plus b squared equals c squared, then the triangle ABC is a right triangle. So now remember, the Pythagorean theorem, not the converse, but the Pythagorean theorem, instead says if ABC is a right triangle, then you can use this a squared plus b squared equals c squared to find missing sides. So that's again where that converse comes from, that flipping of our theorem. So if the second one, or the second part, so if a squared plus b squared is less than c squared, what kind of triangle do we have here? And this is an interesting point, because if you're talking about squaring both of your shorter legs, adding those sums together, and that value, that number is still less than your hypotenuse squared, your c squared, that must mean you have a humongous hypotenuse, which means that if you have a very big hypotenuse, then you have a very big opposite angle. Let me kind of talk about this down here. So for instance, we know what a right angle looks like, but if we go bigger than a right angle, an obtuse angle like this right here, notice how that, horrible drawing, that hypotenuse is so large, and the square of that is going to be greater than the square of the sum of the other two legs. So this over here, so a squared plus b squared is less than c squared. That c squared is actually larger than a squared plus b squared, so we're talking about an obtuse triangle. So again, when you're talking about leg or sides and angles, those are relevant to each other directly across from each other. So again, let me just draw a picture up here. This is kind of a demo of this. So you got a very large C value, and that C, when you square it, is going to be larger than your A and B value. So that's your obtuse triangle. So the other one, if you take the square of your A and add it to the square of your B, and it's actually greater than your c squared, that means, you know what, you've got an angle less than 90 degrees because your c, your hypotenuse is quite squat, quite short. So then we're going to call this an acute triangle. Okay, so the rules go where if the Pythagorean theorem holds a squared plus b squared equals c squared, we've got a right triangle. If it's less than c squared, it's an obtuse triangle. If it's greater than c squared, it's an acute triangle. So let me show you how this is all going to play out. So I'm just letting you know this thing right here, actually watch how important this is. I'm going to actually do this so that you can really make sure that your eyes go to that when we reference it, because we're going to be referencing this a lot. Our example 2, it says, can segments with lengths 4.3 feet, 5.2 feet, and 6.1 feet form a triangle? If so, with a triangle, will the triangle, it should be will, not with, the triangle be acute, right, or obtuse? That should be will. So step 1, the first thing we need to decide is whether or not these three lengths can even make a triangle. So we're not even worried about the theorem, the Pythagorean theorem converse yet. We just need to first know whether it can make a triangle. It's called the triangle inequality theorem. And I'm going to demo it tomorrow in class using pencils, or actually lengths of sides. So we're going to actually show you, or I'm going to show you how this works. But in the meantime, let me just make sure you realize that the sum of two sides of triangle has to be greater than the third side. If it's not, you can't make the triangle work. It can't even meet at the vertices because you have two very small sides, and those two small sides can't meet with that third side. So the sum of the two sides will have to be greater than that third side. If it equals the third side in length, it still can't be a triangle. So really, when we're looking at this problem, we have 4.3 feet, 5.2, and 6.1. We want to add the two smaller values together, the 4.3 plus the 5.2, which are our two small sides of a triangle, and double check that it's greater than the 6.1 to determine if you can even make a triangle. And this, looking at it very clearly, it can, but let's just kind of still add it together. It's 9.5, and 9.5 feet is greater than 6.1. So yes, you can make a triangle. So that's the first thing you need to figure out, because if you can't make a triangle, it doesn't really matter if it's right, obtuse, or acute. It can't even be that. So if this is less than, if for instance this these dimensions you can't even make a triangle, well, you say no, I can't make a triangle, and you know what? You're done. So let's go on to the second part. So yes, we can make a triangle. So now let's classify it. Decide whether it's obtuse. So this idea of classify, we're trying to decide if it's acute. Oops, nope. Ooh, it's not working. I'm not sure why. Hold on. Acute, obtuse, or right. That's what we're trying to figure out. We're classifying it. So we're going to start with that a squared plus b squared. And in this case, we're not going to say equal to anymore. We're going to put a big old space and put a question mark there because we don't know what that is. C squared. If it's equal to, it's going to be a right triangle. If it's less than, it's going to be obtuse. If it's greater than, it's going to be acute. So let's kind of figure this out. The A, now looking at this, the biggest value, which is 6.1, we're going to put in for C because that's going to be the hypotenuse. But let's go 4.3 squared plus 5.2 squared, and we're going to again decide whether it's equal to, less than, or greater than 6.1 squared. And I don't know if you have any guesses, but just looking at these lengths, you know, there's not this, you know, you don't have this humongous hypotenuse in association with those other two legs. So I'm going to bet that this is either going to be a right triangle or an acute triangle. But now let's find this out. So 4.3 squared is going to be 18.5 rounded to the nearest tenth plus 5.2 squared. When you expand that out, it's going to be 27.0 rounded to the nearest tenth. And again, we don't know what this is going to be, whether it's going to be equal, less than, or greater than. 6.1 squared is 37.1 rounded to, not 37.1, I need to do that right, 37.2 rounded to the nearest tenth. When I add these two on the left-hand side, it's going to give me 45.5, which is definitely greater than this hypotenuse squared of 37.2. So that means that clearly it's not a right triangle. And again, just kind of like my gut feeling felt, that hypotenuse is really kind of short in comparison to the other two sides. So this is going to be an acute triangle. And again, if you go right back up to here, we're talking about this last case. A squared plus b squared is greater than c squared. That's what's happening here. We have a greater than c squared, so that is an acute triangle. Thank you for joining me. We'll talk to you soon.